American tank armor in World War II followed a philosophy that differed sharply from both German and Soviet approaches. Rather than pursuing maximum thickness or radical armor geometry, the United States focused on balance, standardization, and industrial efficiency. American armor was designed to be good enough to survive combat, easy to manufacture in enormous quantities, and compatible with a global logistics system unlike anything seen before. At the beginning of the war, American tank armor reflected interwar assumptions similar to those held by many other nations. Early light tanks such as the M3 Stuart featured relatively thin armor, primarily intended to protect against small arms, fire, and shell fragments. These vehicles emphasized speed, reconnaissance, and mechanical reliability rather than heavy protection. Against lightly equipped opponents, this approach was effective. Against modern anti-tank weapons, it was not. The United States quickly learned from early combat experiences in North Africa. Encounters with German anti-tank guns revealed the limitations of American armor, thickness, and layout. Unlike Germany, which responded by increasing thickness and complexity, the US response focused on incremental improvement combined with overwhelming production. Armor was reinforced where necessary, but radical redesigns were avoided to prevent disruption of mass production. The M for Sherman became the defining symbol of American armor philosophy. A Sherman produced in one factory behaved much like a Sherman produced in another, a crucial advantage in large-scale operations. Internal survivability was another area where American armor philosophy differed. The US Army placed increasing emphasis on crew protection beyond mere armor thickness. Early Shermans suffered from ammunition fires after penetration, leading to catastrophic losses. In response, American engineers introduced improved ammunition storage, including wet stowage systems that dramatically reduced the likelihood of fires. This innovation saved countless crews and highlighted the American focus on survivability rather than invincibility. As the war progressed, American tank armor evolved incrementally. Later, Sherman variants featured thicker frontal armor, improved turret designs, and better steel quality. These changes did not transform the Sherman into a heavy tank, but they increased survivability without sacrificing reliability or production speed. The result was a vehicle that could remain effective across a wide range of combat environments. Heavy American tanks followed a similar philosophy. The M26 Pershing represented a step toward greater protection and firepower, but it did not abandon the principles of standardization and maintainability. Armor, thickness, steel quality, and internal protection were optimized for this purpose, not for spectacle or intimidation. American tank armor in World War II therefore represents a different definition of success. It was not about creating the most feared tank on the battlefield. It was about creating a force that could fight anywhere, be replaced quickly, and sustain operations indefinitely. This approach would prove decisive not only in Europe, but across every theater where American armored forces were deployed. Understanding American tank armor requires understanding American industrial strategy. The United States did not seek to out-engineer its enemies in isolation. It sought to outproduce, outmaintain, and outsustain them. Armor was one element of this strategy, carefully balanced against every other requirement of global war. As American tank armor was tested across multiple theaters of war, its true character emerged not through isolated technical superiority, but through adaptability under pressure. Every engagement became a data point, every loss a lesson, and every improvement a calculated adjustment rather than a radical shift. In North Africa, early encounters exposed the limitations of American armor when facing experienced German crews and well-positioned anti-tank guns. Shermans operating with relatively thin vertical armor were vulnerable to high-velocity weapons, particularly when advancing without adequate infantry or artillery support. These losses did not trigger a complete redesign of American tanks. Instead, they reinforced the belief that armor effectiveness depended on how tanks were used rather than how thick their plates were. American doctrine emphasized coordination, reconnaissance, and overwhelming firepower to compensate for armor limitations. One of the defining strengths of American armor was steel consistency. These changes were not elegant, but they were effective and quick to implement, reflecting the American preference for solutions that worked immediately rather than those that looked impressive on paper. While it was indeed less protected than German heavy tanks, it was never intended to fight alone. American combined arms doctrine ensured that tanks operated alongside infantry, artillery, engineers, and aircraft. Anti-tank guns threatening Sherman units were suppressed by artillery or neutralized by infantry. Enemy armor was engaged with numerical superiority in air support. In this environment, moderate armor proved sufficient to keep tanks operational long enough to achieve objectives. Internal survivability improvements marked one of the most important evolutions in American armor design. Early Shermans were prone to catastrophic fires when ammunition was ignited after penetration. This weakness directly threatened crew survival and undermined confidence in armor protection. The introduction of wet ammunition stowage transformed this dynamic. By surrounding ammunition with water-filled jackets, engineers dramatically reduced the likelihood of fires. This change did not increase armor thickness, but it saved lives and allowed crews to continue fighting after hits that would previously have destroyed the tank. American tanks might be penetrated, but crews often survived, escaped, and returned to service. Later Sherman variants incorporated thicker frontal armor, improved turret designs, and better ballistic shaping. While these changes did not make the Sherman impervious to German heavy guns, they narrowed the protection gap and improved survivability. Crucially, these upgrades were introduced without disrupting production. Factories continued to deliver tanks at an extraordinary pace, ensuring numerical superiority remained intact. The introduction of the M26 Pershing highlighted both the strengths and limitations of American armor philosophy. The Pershing featured significantly improved armor protection and firepower, addressing the challenge posed by German heavy tanks. Its sloped armor and thicker plates offered better resistance to high-velocity guns, bringing American armor closer to parity in direct engagements. However, the Pershing arrived late and in limited numbers. Its delayed deployment underscored the American belief that existing armor solutions, combined with overwhelming production and air superiority, were sufficient to win the war. American armor effectiveness was also shaped by superior battlefield recovery and repair capabilities. Damaged tanks were often recovered, repaired, and returned to service rapidly. Armor that could be welded, reinforced, or patched in the field proved more valuable than armor that resisted penetration but was difficult to repair. This logistical advantage multiplied the impact of American armored units, ensuring that losses did not translate into permanent reductions in combat power. In contrast to German late-war armor, which suffered from declining quality and mechanical fragility, American armor maintained consistent performance throughout the conflict. Steel quality remained stable, production standards were enforced, and supply chains remained intact. This consistency reduced uncertainty for crews and commanders alike. Knowing what armor could and could not withstand allowed for more confident planning and execution. American tank armor also benefited from the global reach of U.S. industry. Armor solutions could be tested, refined, and implemented across multiple theaters simultaneously. In the Pacific, American armor faced a different set of challenges. It delivered predictable performance, supported relentless operations, and integrated seamlessly into the broader machinery of Allied warfare. In doing so, it helped define a modern understanding of what effective armor truly means. By the final stages of World War II, American tank armor had demonstrated that its true value lay not in intimidation or extreme protection, but in sustained effectiveness across an entire global conflict. This operational maturity transformed the Sherman from a perceived liability into a dependable instrument of combined arms warfare. The introduction of the M26 Pershing represented an acknowledgement that heavier armor and firepower had a place within the American arsenal. The Pershing's armor offered improved resistance to German heavy guns, and its sloped frontal plates reflected lessons learned from both Allied and enemy designs. However, the limited deployment of the Pershing underscored a critical point. American victory did not depend on matching German heavy tanks one for one. It depended on maintaining momentum, supply, and coordination at a scale the enemy could not sustain. One of the most significant advantages of American armor was its integration into an unmatched logistical system. Tanks did not exist in isolation. They were part of a continuous flow of production, transport, maintenance, and recovery. Damaged vehicles were recovered rapidly, repaired efficiently, and returned to service. Armor that could be restored quickly multiplied combat power far more effectively than armor that resisted penetration but remained out of action after damage. American steel quality remained consistent throughout the war, a reflection of industrial stability. Unlike German late-war armor, which suffered from material shortages and declining quality, American armor plates retained predictable behavior under fire. This consistency reduced uncertainty for crews and commanders alike. Knowing what armor could withstand allowed for informed tactical decisions and reduced the psychological strain associated with unreliable protection. Crew survivability continued to shape American armor philosophy. Improvements such as wet ammunition stowage, better fire suppression, and additional escape hatches reflected a deliberate effort to preserve trained personnel. Even when tanks were lost, crews often survived. These experienced crews could be reassigned, retrained, and returned to combat, preserving institutional knowledge and improving overall effectiveness. In contrast to the myth-driven narratives surrounding tank warfare, American armor demonstrated that survivability is not solely about resisting penetration. It is about minimizing loss of life, maintaining operational continuity, and enabling rapid recovery. A tank that is penetrated but repairable and whose crew survives may contribute more to long-term success than an invulnerable tank that is too rare or complex to replace. The American approach also benefited from constant evaluation and feedback. Reports from the field informed engineering decisions, training programs, and tactical doctrine. Armor design was never static. It responded to real-world conditions rather than theoretical ideals. This adaptability ensured that American tanks remained relevant across different theaters. From the hedgerows of Normandy to the islands of the Pacific, by the end of the war, American tank armor had proven its effectiveness not through dramatic duels or legendary reputations, but through quiet reliability. American armored units advanced steadily, supported infantry assaults, exploited breakthroughs, and sustained operations across vast distances. Armor played its role as part of a larger system that emphasized coordination, endurance, and overwhelming force. The legacy of American tank armor in World War II lies in its influence on post-war military doctrine. The emphasis on standardization, repairability, and crew survivability became foundational principles in modern armored design. Future tanks would continue to balance protection with mobility and logistics, reflecting lessons learned from American wartime experience. Understanding American tank armor requires moving beyond simplistic comparisons of thickness and penetration. Its success was measured in campaigns won, supply lines maintained, and forces sustained over time. Armor that supports long-term operational effectiveness ultimately proves more decisive than armor designed for isolated superiority. In the broader context of World War II, American tank armor exemplified a pragmatic approach to warfare. It accepted vulnerability as inevitable, mitigated its consequences through system-wide solutions, and leveraged industrial strength to maintain momentum. This philosophy allowed American armored forces to remain effective from the first engagements to final victory. In the end, American tank armor was not designed to dominate the battlefield alone. It was designed to function as a dependable component of an immense and coordinated war machine. That reliability, more than any single technical innovation, ensured its success. Through consistency, adaptability, and integration, American armor helped carry the Allied forces to victory, proving that in modern warfare, endurance and systems matter more than spectacle.